Alright, today we're going to talk about solving linear and literal equations. Linear equations are equations that are dealing with lines. This is going to be a review for you. It's nothing really new, just a refresher. And then literal equations we'll talk about in the second part of the notes. This is when you're solving for a variable. The big thing with lines is that we're talking about equations that only have an x, not an x squared term or any other exponent. Okay, so let's go ahead and solve the first one. 5x minus 2 equals 8x minus 11. So some things that should be going through your head right now are that you're trying to move your variables to one side and your numbers to the other. So I'm going to start by subtracting the 5x over and adding the 11 to the other side. Divide by 3 to get x by itself, and you get x equals 3. Pretty simple. It's important when you're solving these equations to always check your answers. So what I mean by that is plug in your answer for x on both sides and make sure that the right-hand side equals the left-hand side. So in this case, 15 minus 2 is 13. On the right-hand side, 24 minus 11 is also 13, so it does check. Alright, for the second problem, some important things to think about: how to get rid of parentheses you want to distribute. So distribute the 3 first. We've got 6x plus 3 equals 4x, and then on the other side all we're doing is distributing our negative. So minus x plus 15. Then I'm going to combine like terms on one side first. 4x minus x is 3x. Then I'll go ahead and move x's to one side, numbers to the other. So I'm left with 3x equals 12. Divide by 3. And for this one we get that x is 4. Again, you can probably just do a mental check. 2 times 4 is 8, plus 1 is 9, times 3 is 27. On the other side, 4 minus 15 is negative 11, so 16 minus negative 11 is also 27. So this one also checks. Okay, moving right along. Question number 3. Okay, question number 3. At first glance, this one doesn't look too challenging, but if we take a look, 12x minus 2x on the left is going to give us 10x plus 5, and on the right side we have 10x plus 5 also. So if I go about moving variables to one side, the problem is that all of my x's go away, and I'm left with something like 5 equals 5. In a situation like this, 5 does equal 5, so this is something that's always true. So our answer is going to be all real numbers, and this is also known as an identity. We have the same thing on the right hand side as we do on the left hand side. Okay, the next one is a little bit trickier because we have fractions. We love fractions. What I'm going to suggest that you try to do, just like I think I did at the beginning of the year, is that you clear out your fractions by multiplying through by a least common denominator. So for this problem, 2, 4, and 3 are the numbers in the denominator, so 12 is going to work as my least common denominator. So I'm going to multiply everything in this problem by 12. 12 times 1/2, or 12 divided by 2, is 6x. 12 times 2 is 24, divided by 4 is plus 6. And then same thing on the right hand side, 12 divided by 3, that's the trick. Take this number 12, divide by what's in the denominator 3, so you get 4x. And then here's the other clue, you have to remember to multiply 12 by 5 plus 60. Now this problem is much simpler to solve. So again, I'm going to put a little note here, multiply through by the least common denominator. Okay, now this is an easy problem to solve. Variables to one side, numbers to the other, and we get that x is 27, and it does check. Okay, question 5. We can also start by rewriting this. So there's a few ways that you can do this one. I'm going to start by just writing it 7x minus 2 over 4 equals x plus 7 over 3. And the reason that I'm doing this is because now this turns into a cross multiply problem. So I'm going to have 3 times 7x minus 2 equals 4 times x plus 7. Now again, this is a really simple problem to solve. Just go ahead and distribute. So 21x minus 6 equals 4x plus 28. Variables to one side, numbers to the other. So I end up with 17x equals 34. Divide by 17, and I'm going to get x equals 2. Now for these, it is important to check that you don't get 0 in your denominator when you plug your answer back in. But since I have 4 and 3 in my denominator to start with, it's not a problem. Okay, for question 6, because there's more than one fraction on each side of the equal sign, I'm going to multiply through by the least common denominator again. So this time the least common denominator is going to be 9 and x. 9 because 3 and 9 both go into it, and we also have an x in there. So for the first term, the x's cancel. 9 times 6 is 54. For the second term, the x's cancel. 9 divided by 3 is 3. So I'm just going to write it for now plus 3 times x plus 2. And then for the right side of the equal sign, the 9's cancel, and this is going to equal x. Okay, so go ahead and distribute. Variables to one side, numbers to the other. And for this one, I get x is negative 30. Again, I want to do a mental double check and make sure that I don't get 0 in the denominator, but in this case I don't, so I'm good to go. If I plug in negative 30 here and here, neither one gives me 0 in the denominator. Okay, one more with fractions. Again, I'm going to start by multiplying through to clear out my fractions, but even before I do that, this time I'm going to need to factor this first denominator. So this denominator is going to factor a plus 5, a plus 2, which is convenient because that's what I have in my other two denominators. So the least common denominator that I'm going to multiply through by is a plus 5 and a plus 2. So for my first term, both parts in the denominator cancel, and I'm just left with 2a plus 1. For the second term, the a plus 5's cancel, but I'm left with the a plus 2 group. And for the third term, the a plus 2's cancel, and I'm left with 4 times a plus 5. Again, now that I've cleared out the fractions, this is a much simpler problem, so I'm just going to go ahead and distribute. I'm going to combine like terms. 2a minus 3a is negative a, 1 minus 6 is minus 5. Move my variables to one side, numbers to the other. And I get that a is negative 5. Now, is anyone paying attention? Do you see what's wrong with this answer? What am I going to get in the denominator of my middle fraction? Negative 5 plus 5 is 0. So for this problem, I'm actually going to cross my answer out and say that my final answer is no solution. You have to remember to double check no zeros in the denominator. Okay, so what were some of the keys to solving that I mentioned when we were solving these? The first one would be to put variables on one side, numbers to the other. The second would be to undo fractions by multiplying by the reciprocal. The third one would be to clear out fractions before solving if possible. And then the fourth one would be if variables drop out and the resulting statement is true, we have an identity, so our answer is all real numbers. If what we were left with was false, like 0 equals 1, then we would have a contradiction, so we would write no solution. Okay, now we're going to build on what we were just talking about a little bit. When we talk about classifying answers, the first type of equation that we can have is called a conditional equation. This is the kind of equation that you're used to seeing. It's satisfied by some numbers but not all, aka there is an answer. This is what you see probably 90% of the time. An identity is an equation with all real numbers as the solution set. So like we saw earlier on the front, if you are left with something that's true, like 2x plus 1 equals 2x plus 1, or 0 equals 0, or 5 equals 5, that's something that's always true, so it's all real numbers, and that's called an identity. A contradiction is an equation with no solution. This is when you're left with something that's not true. 1 equals 5, 0 equals 3, any case where that's not true. Okay, the second part of our notes, we're going to talk about solving literal equations, which is solving for a specified variable. Basically, this is just rearranging the equation so the variable you want is by itself. Okay, so for the first one, we want to solve for y. You guys have done this lots of times by now. You are solving for y usually when you're graphing. So the first thing I'm going to do is move over the 2x. I'm going to try to get that out of the way. Out of habit from always graphing lines, you're probably used to putting negative 2x plus 7. And then to solve for y, we need to divide every single term by 5. So our answer here is going to be negative 2x plus 7 all over 5, or you could write it as separate fractions, negative 2 over 5x plus 7 over 5, which probably looks a little bit more familiar to you if you're thinking about graphing a line. Okay, the second one changes gears a little bit. Now they're asking us to solve for h in a formula from geometry. Volume equals 1/3 area of the base times the height. So first thing we probably want to undo is getting rid of the 1/3. How do you undo a fraction? Usually by multiplying by the reciprocal. So to get rid of 1/3, I'm going to times both sides by 3. So now I've got 3v equals b times h. And now the easy part, just go ahead and divide by that big B. So we have 3v over b equals h. Now, I am going to put a note here that it would not be correct if you did not know how to get rid of your fraction and left 1/3 in the denominator. That's not okay. We do not want to have fractions within fractions. So you do need to know to undo fractions with the reciprocal. Okay, our next one, again, gives us a little bit of a twist. They want us to solve for p, but there's more than one p in the problem, and there's also fractions in this problem. So I'm not a big fan of fractions. I think the very first thing I'm going to do is multiply everything by 2, because that's going to clear out my fractions. So now I've got 2a equals just 1xp plus 1yp plus bp. Now, I suppose you could work with your fractions, but this just looks much more manageable to me. The other issue that we have on this one that's different is that we have more than one p in the problem. So the first thing I need to do is move all of those p's to one side, which we already have, and then I need to factor it out. So that's going to leave me p times x plus y plus b on the right-hand side. I've still got 2a on the left. Now, to get p by itself, I'm just going to divide by everything that's in my parentheses. So my final answer is p equals 2a divided by x plus y plus b. Okay, now we're ready for the last one. We need to solve for h here. This is one kind of similar to the last one where we have more than one h in the problem, but unlike the last one, we don't have all h's on the right-hand side. So the very first thing I'm going to do is just move over the term that I don't need, the 2 pi r squared, and I'm going to move that over with subtraction. I'll go ahead and leave the right-hand side for now. My next step is going to be to go ahead and factor out that h now on the right-hand side. So I'm left with 4 pi r plus 6b in my parentheses. And then to solve for h, I can just divide everything by what's in that parenthesis. So final answer is going to be h equals z minus 2 pi r squared divided by 4 pi r plus 6b. So just remember that we always need to undo addition and subtraction first, and then finish with multiplication and division. It's the reverse order of operations, and that should help when you're doing your solve for variable problems. All right, good luck on your homework.